Welcome back to another video in HandsOnCV. This session we will see about a video. What is video? Then we'll jump into Visual Studio Code and type some Python command. Keep your hands dirty by coding. After that we will learn some cool stuff like background subtraction. Then finally we will do our own face reduction with our hand. Okay, it's interesting. So here what prerequisite is, right? Please watch the previous video what we have shown, where we will have a complete image processing and how to read a video, how to use Visual Studio Code, how to run a Python file, how to apply the What is video? Yes, in this animation you can see this is an image and a sequence of images. A sequence of images with minor changes forms a video. So we will call it as frame. So the first frame, second frame and continuous frames, then a small change in each frame will form an action. What is video? We have seen videos are a collection of frames, and here frames represents a single image at one instant time. And how many frames will be present in a video? Let's analyze here. In a video, let's take a video having 1 minute of duration, so it has 60 seconds and each second has 30 frames. So the number 30 is a common number in most of our videos, and if you have a slow motion video, the frame rate, they will call it as FPS, number of frames per second, will be 240, and if you have high tech ultra slow motion video, you will have 2000 frames per second. But usually in an ordinary movie or ordinary videos, YouTube videos, it will have 30 frames per second. So if you take 30 frames per second ordinary video for 1 minute, that is 60 seconds, total number of frames we'll get is 16 to 30, it will be 1800 frames. Think of, so 1 minute video we have to represent with 1800 frames. It's huge, right? So if you want to represent a big movie of 2 hours, so it will be like huge, the number of frames, number of images. So how we efficiently save these images in a single container? We'll call it as container because it contains the images. So how efficiently we can do this? Let's see. So here it's an interesting phenomenon they have used. Instead of saving every information and every minute frame information, they have reduced the information but without any loss. Okay, it's interesting. So here let's see here, and this is the green color is called iframe. Iframe is a complete image, and consequence frames, they will call it as p frames. So the pre frames holds only the changes in the image from the previous frame. So if you have the one complete image and you'll have very minimal informations about the changes from the iframe, in this way you can reduce p frames informations, because if you have very small changes, if you have a still camera or news reader, so only the lips may change and sometimes the face may change, but the whole background is common, so it will contain the difference. So the difference will be just 0, and only where changes it will have some information. So in this way, iframe will be a complete image and p-frame will be the difference. So in ordinary images, ordinary videos, will have around one iframe
Create
have
a new
18
file,
p-frames.
video processing.py, and as usual we load numpy, and also we load the CV2 OpenCV library. Now video file, this is a video file path I would like to give. So I have already copied one video file here, the same folder where my code, so please have your own video here, and you can give the full path of the video by copying and copy path. So I give R to avoid confusion with video path in Windows and Linux. So let's read a video. I'm keeping my name as video. Here I will keep cv dot im video capture and giving a video file. Then yes, my video has got written. Then my video has got read, and here while true, everlasting loop while true, then I'm reading the video. So here return comma frame equal to video dot read. As I have explained you that video is a set of frames, so what it will do, the video capture is the object of whole video, and video read will read every frame one by one when you query this. So once you query this, it will give the first frame, then after a while loop ends it will go to the second, then it will go. So it automatically keep track of what is the current frame, and it produces the next frame whenever we call video.read. Then as usual we have seen im show frame comma frame. So we have seen in the first video how to show an image. Then also we have seen wait key. You may understand that it is 0. If you give, it will stop until we press some keys, but here what we are doing is a video, so I need a continuous frames here. So what I will do, right, so I will give some number. Let's see first, let's keep 0 and see, and we can change again what needs to be given here. So everything is done here, and I'm going to play. So play button, and your video comes here. This is your first frame in your video, and I'm pressing a space, and this is the next frame, next frames. I am continuously pressing the space, and you can see nice vault. Okay, whenever I press the space, the next frame comes, and you can see this. Okay, okay, let's see here what are the things. This is a very basic one, how to do things, and now we have to do in a correct format. So what is frame and what is RET? So RET is written, so we have kept an everlasting loop here, and this loop won't end, so we should not do that. So we have to have some condition for break. So whenever while is there, you should write a break there. I'm writing a break. So here written, if written is true, then it has some videos, but if we come to a last frame, written will give a 0, or the video is not a valid video, it will give a false. So let's none, I think so. Yep, run. So written is none. I am returning, sorry, I am breaking the while loop.
Same thing, right? So I have seen the video that the video never, if you press space, it goes the next frame, it never goes automatically. So here, if instead of giving a 0, if I give some value, so the best value, if you have a video of FPS 30, you have to give 33. Okay, this is millisecond, so every 33 millisecond it will wait for 33 millisecond and it will go to the next frame. And also, right, you are pressing space. So instead of doing this, what I'm going to do, right, the video will run until I press space. It automatically runs and it closes when I press space. So I will keep character equal to CV. So the wait key will give the character what you press. So if character equal to 32, this is a space. Pressing space, I am breaking the video. Okay, so you can understand here, I'm taking the video file and opening a video capture, then I'm reading the video and I'm running it here, and you can see video and the video automatically finishes. I'll do again, the video runs and automatically finishes. Yeah. If you have a webcam in your system or your laptop, how do you render the webcam here? It's not very tough, it's very simple. Here, right in the cv.video capture, here instead of video file, I'm just giving 0 here and I'm running again. And you can see me here. So this is a webcam and it's live here. So you can stop by pressing space. I have 2 webcam, so I'm going to use a second cam. So you can click here, instead of 1 I'm giving 1. This is a second webcam. Same here, I'm pressing play button here. Okay, this is another view of the webcam, and through this you can play around with all the webcam video you read, and you can live telecast or live or process real-time web detections and things you can do using webcam. Background subtraction is nothing but removing the background and just keeping the foreground. In this image you can see, right, so the hand which is moving and the background which is not moving, and the hand is taken out separately in the background subtraction algorithm. And whatever a background, the machine learns the background, and if some changes happen in foreground, so in this image this black color denotes the background, and here this white color denotes the foreground. So when there is any motion, this foreground highlights and take that motion as foreground, and all the other thing there is no motion or a continuous motion, it will consider as background. Background subtraction applications. The very first one is vehicle counting. So when we have a static camera which may fixed in some pole, and if a vehicle moves and the road and every other things are stationary, we can easily pick the road information and it learns that as a background, and when a car moves on the car considers foreground. Through that we can count vehicle, and also we can measure the speed of an vehicle by checking how much this blob moves. Same thing also we can do for person counting, and also it can be used for motion detection. Background subtraction can be done by mixture of Gaussians. I will explain you nicely here. Let's take an image and another pixel here. So once the image, and we are taking only one pixel for now, and we are going to take first 20 frames in the video, and we are taking one pixel. Just let's take for analysis only one pixel here and get all the information for 20 frames. Then we will get all the numbers for that frame, for the 20 frames. Then we take the mean of the all the 20 numbers and standard deviation of the 20 numbers. Then we represent this data in normal distribution. We will call it as Gaussian distribution or normal distribution. So Gaussian distribution looks like this, where you can have a mean at the center, and standard deviation is the wideness of the curve. So it's a bell curve, and you can see, right? So here this graph represents a normal. We can call it as normal or Gaussian, both are same. So here the mean is 0 and the standard deviation is 1. So standard deviation is how much the mean is deviated with other data. So you can see by this formula you can easily generate this Gaussian distribution. Generating this distribution is called training. When a new frame comes, and we will get the same pixel for that new frame, and we will check whether the point is outside or inside of the Gaussian distribution. If the frame pixel value is outside, then we will consider this as a foreground, and if the pixel is inside, then we will consider as background. We'll learn about how to create a mean and standard deviation. Through that we get a distribution. So mixture of Gaussian is nothing, but now we are in the left hand side, so we cannot represent the data with a single Gaussian curve. So we want to represent by a mixture of Gaussian curve. So the number of Gaussian, if we fix it, it automatically finds the Gaussians like this. So Gaussian can be represented by two values. One is the mean and another one is the sigma. So one pixel will have how many mixture we want, that many mu's and that many sigmas. Okay, so I need 3 mixture of Gaussian, and then I need 3 mean value and 3 sigma value to represent the pixel arrangement. So here I already explained to you. Here these are the 20 frames, and for each pixel we are going to take that many Gaussian distribution. So if we have 600 into 600 pixel, then we'll have 600 into 600 mu's and standard deviation sigma. If you have mixture of Gaussians into 3, then it will be huge. Okay, but you know the process is very simple, multiplication and addition, so it won't take time. And whenever, let's see, I'll explain again here. Here these areas in the background, okay, it is a clustered area, but what happened, right? These areas are being trained and we arranged a Gaussian distribution for this area. But in this area, right, so I will draw here. So this area right here also they have white and black as a background, but when a new hand comes, when this hand comes, it will not obey and it will be the outlier in the Gaussian distributions, like you know, like somewhere here and here, not inside the bell curve. So this area will highlight as 1, and the other area where there is no changes and it obeys the Gaussian distribution, it will become black. Let's do the hands-on CV. Create a new file, background subtraction .py, and I'm copying what I have done in the previous session, and in here I don't need the video path. I'm going to do in my webcam. Here I'm going to use the first webcam, that is 2 webcam in my laptop and 0 on 1. So please keep this as a template. You always copy paste, you don't need to write every time this thing, because it's a template to read a video and display here. Let's see here how to do our background subtraction. So in OpenCV, it's a few lines you can do the background subtraction. Let's do and play. Type, let's say PG subtractor. PG means for background, and cv.create background subtractor. You can see there are 2 background subtraction. So I'm going to use MOG 2. So this is mixture of Gaussian. We have seen the theory how it works. Then we are going to apply the background subtraction. The same thing, I'm reading a webcam, then I'm having a everlasting for loop and having a break condition if a video fails. Then I'm showing a video frame here. Then I'm applying the background subtraction. Background subtraction. It's very simple here. So dot apply frame, and here, right, when background subtraction, we will get a foreground, not foreground, we will get foreground mask. Mask in the sense of binary, where there is a background will be black, and wherever a foreground presents, it's white. So we will call it as mask in whole computer vision field. And I'm going to see the background foreground mask. CV IM show. I think you guys have familiar with this IM show, but always keep a very good name to have a good understanding, and when you rerun it, you can understand what's happening and can easy to debug any problem here. So wherever IM show is there, you should have a wait key, and we are having a wait key here. You can have multiple IM show and only one wait key for everything. I'm playing this. Okay, here you can see me, and you also see the mask where it doesn't have any background and it's only my foreground. So one thing you should understand here, right? So when there is a movement, the background is strong. When there is no movement, and the background will fade away. So I am keeping my hands for a while like this, without any motion it will become black, because there is no movement, then it will consider as a background. It's nice that we have a Gaussian theory, and we know, right, it learns from the last 20 to whatever 100 frames, and it learns the Gaussian map and it is keeping it. Okay, so whenever I'm having small shake, but it is nothing, but when I have a very good shake and I'm changing my hands and keeping things, I give good. Already we have learned about image processing, how to do spreading or making small holes be filled by image processing. So we have seen, if anyone haven't seen, please see the image processing video in the about description box. Foreground mask equal to, so what I'm going to do, right, I'm going to fill small dots, and we are seeing some ugly dots in everywhere and it's not clean. I'm going to make it clean. So foreground mask equal to NP array. I'm first applying a threshold for this foreground mask. About 50 should be my foreground mask. Then this is my U8. And now
I'm multiplying my foreground mask with 255 because the above one is 0 or 1. I'm going to multiply with 255, so all the zeros will always 0, but if it's a 1 it will become 255. Now we are going to see our foreground mask with a clear background subtracted mask. Before that we already seen that morphological operation, so I'm going to apply our morphological operation. The best thing to fill the small dots. Do you remember? Yes, it is I am close. To learn I am close, I'm dilate, or to learn about how to spread, how to fill small holes, or how to remove some artifacts outside, please see the previous video, image processing video. It's an hour-long video and it's more interesting, and you learn edges in that video. Applying a foreground and operation. My operation is morph close, and my kernel is np1s of shape 25, 25. Yep. Then now we are going to see our modified foreground mask. Here, play. Yeah, so now you can see my things, and it is not like a dot on. My mask is clear and things. If it is not moving, you'll get small. That small square box determines your dilation shape. Okay, now what we are going to do is just taking the foreground using the mask from the frame. So instead of showing a white color mask, I'm going to show myself on the screen without a background. It's interesting and it's very important in computer vision, these basic steps. Keeping the foreground using the mask. Okay, here we are going to use a bitwise operator, and I'm giving a name foreground equal to CV bitwise operator, and apply and frame, and I'm multiplying and also multiplying with the frame but with a mask. So my mask is foreground mask. So you can understand here I'm just adding frame and frame with a mask. So I'm not doing anything, just applying my mask here, and here I will show, the video will show only myself and it will remove my background. Let's see. Before that we need to type the show, I am show, and I am name it as foreground and giving foreground. So here the main mistakes people usually without giving the name, just give the name of the variable instead of giving a name of the window, it fails. So these are some of the common mistakes even I have faced a lot. Another common mistake, right, in here in NumPy, a lot of people including me, I give instead of u unsigned int 8 unit 8. So, okay, so it's a little confusing. I'm playing this. Let's see how my foreground. So you can see a frame here, and you can see the background minimized, only the foreground, and here we are seeing the foreground without my bad cluttered background, and you can do by yourself on your video for you. Okay, so instead of doing just sitting and doing, if you walk and things, if you changes your position in your screen, the mask also applied very nice, and it covers. So if you want a vehicle counting or any person counting, this is a very nice application, please try out. Now we are going to see the face reduction. It is one of the interesting and amazing we have seen on all mobile applications and everything. The face reduction, and the face is nothing but just finding the coordinates where the face presents in an image.
and here we are going to see a decade old and still being used in a lot of mobile cameras and in cameras, digital cameras, Paul Viola and Michael Jones detector, face detector. So we will call it as Viola Jones detector, and it is one of the best one, and now a lot of deep learning models overcomes this, but this is one of the best and it stands for 10 plus years. Let's see the Viola Jones detector, face detector. A very simple theory, and I don't want you to jump into the theory, just have a insight what's happening, and it's interesting. I like this concept. So the first one are like features. This is one of the machine learning technique here, but it's very simple way of training the model and getting the feature, and it is real time, it's very fast. So jump in. So hard-like feature, it's very weird way of finding the informations on the image, where this is a box, let's call it a sliding window, and the sliding window, wherever white, this A, B, C, D, where the A, B and D are white and C is black. So feature is nothing but just some of the pixels inside the A and some of the pixels inside the B and some of the pixels inside D. Then we subtract the pixel which are present inside the C. Nothing, just adding all the white and subtracting the black. In this way we will get the feature. This is just a number. By adding the information inside A, B and D, then we are subtracting C. This is one feature in hard-like. So like this we will have a lot of hard rectangle features. So instead of having 4, we may have 2, or we may have vertical 2, or we may have 3, or we may have 4, but as common, you have to add the white color pixel and subtract the black color box pixels. Just summing this thing will get the features. So how this feature reacts on the image? Okay, so let's see, this is one of the feature. This is one of the feature here, and I'm keeping this feature in the face, and here we get some number, and we are keeping the pixel in here and we get the number. This number commonly be common for all the faces, because we'll get the eye line here and we'll get some eye information, and it should common for most of the all the human face, and this also we will find these changes. Okay, so through that we will get lot of features by just adding and subtracting the number of pixels in the boxes. Okay, but one thing, if you are adding all the pixels and all the subtracting the number of pixels, what will happen? Huge number of computations, and I'm just showing 4, but it will have more than 256, or I think more than 1000 these hard-like features are there. Calculating, summing, subtracting, it's huge calculations for each pixel. So how do we run this as a real-time application? Okay, so Paul Viola Jones found another one called integral image here. So integral image is nothing but, so instead of adding all the pixels inside that, we are just taking the last pixel and the last pixel and do the process. How can it be possible? Okay, so integral pixel is nothing but just adding, I will take the laser here. Okay, just adding the first frame with the second and keep here in the second frame and adding this and adding with the previous one, and it will become 7, then adding 2 with this 9. So you can here, I will explain you here, the 4 will be 4 and 4, this 4 plus 1, it will become 5, and this 5 plus 2, it will become 7, and also this 2 plus this 7 will become 9. And let's check this here. This 9 is nothing but sum of this 5 and this 4. Okay, in this way we will do all the calculations here. Okay, so in this way it will have all the information. This we call it as integral image. So integral image will be calculated only once on the image, and the hard informations like adding, just subtracting the last information, last row and column pixel value represents the sum of the information here. So now we have seen what is hard-like feature. So like this, we'll take around 1000 plus hard-like features by a simple integral image. Let's see the hard classifier. So we have seen what is hard feature, and hard feature is nothing but sum of boxes, and we are adding the white boxes and we are subtracting the negative the black boxes. And hard classifier is nothing, the feature value we are applying a threshold. Let's take the feature value will be 25 and we are applying a threshold like 5 or 10, and if that feature value is above that threshold, and it will be true, else it's false. Very simple. Whether if the feature value, the feature here, if you see in the face you have this, and this is one of the hard classifier, sorry, hard feature, and we'll have sum of this A, and we are subtracting this with B, and this value will be applied by a threshold. And if the threshold value is above some threshold, if the value is above the threshold, we'll call it as positive, and if the value is less, we'll call it as negative. So very simple, and we call it as a weak classifier. Just applying a threshold for a number, it's a false, but it is a very weird one, very very super simple. But how it works, yes, it works, right? Instead of having only one condition, if you have thousands of conditions, okay, not only one hard classifier, if you have a lot of classifiers, this works. That's miracle. So how it works, right? So this is an image and you are applying a sliding window. First we'll keep the image, keep the sliding window on it, and take this image and apply the hard classifier, get all the features and applying the threshold. Let's say whether it's face. So the sliding window moves with a different scale. Okay, this is one scale and we'll have more than one scale, and moves from start to end, and if it finds any face there, it will mark it as true, otherwise it will be false. Okay, so I don't want to get into more theory here. So this is our cascade classifier. I told you, right, a single hard classifier cannot find the face, but if you have lot and lot of hard classifiers, we will get the output. Okay, so it will have stage 1, stage 2, stage 3, stage 4 up to n stages, and each stages has an option to reject. And once it is passing the first stage, it will go to the second stage, and if it passes the second stage, simple threshold, right? So it passes the second stage, it will go to the third one, like that. If small 24 cross 24 sliding window passes this, it will reach the acceptance if it is a face, otherwise it will get rejected. And these are weak classifiers. This is not a stage 1 is not a single classifier, it has a group of hard classifier. And what this stage 1 will do, right, it will reject faster. Okay, if it didn't find any with a weak classifier, but if it says this is just a plain wall, I'll reject it, it's not a face. Okay, but it finds very small change. Okay, yes, it looks like some face, then this guy will send it to the next stage. Okay, next stage it will do little minor calculation, it will do little minor verification. It's like verification. It's we have to do the first stage. Once you clear it, it will go to the next stage, and it clears it, go to the next and next. Okay, but one thing you should understand here, that this stage 1 rejects lot of slides. So what will happen, right, the system will be very fast. Okay, so if I image escapes stage 1 and going to stage 2, then going to stage 3, stage 4 and n-1, then it reaches nth stage, a very strong classifier, because it was rejected by everything, and it confirms that it is accepted, then it is a face. Okay, a sliding window will convert into face, or sliding window will be confirmed as face if it goes successfully through all the hard classifiers. So we will call this as a cascade classifier, because it has a lot of stages, a continuous series stages. A weak classifier combined with lot of weak classifier became a stronger one. Okay, so here how we train this model, we have a lot of how do you fix the threshold is called training here, and how to arrange the number of hard classifiers in each stages, and these things are you can do it manually. But how do you fix the threshold, right? In the previous frame we have seen, right, a hard classifier works on the threshold value, and how do you fix the threshold will be happen on the training process. We'll give a lot of images inside, and we will get the value when it finds the face, and by each threshold fixing is called a training process. And once the training is done, then we can run. I don't want you to jump into this Weiler-Jones detector, because it's huge, and the training process and everything. Nowadays we have deep learning, and we are going to learn deep learning, and we are going to do hands-on deep learning. And I don't want you to train a hard classifier, train a model, because our deep learning is much powerful and much easier. So let's learn what's happening in the hard cascade classifier. Just know the theory, but don't do the training. But we utilize the face detection, and we run our inference on face detection, and do our face detection and also eye detection in the hands-on session. Let's do face detection in OpenCV. I'm going to create a new file, face detection.py, and instead of typing everything, I'm copying from video processing.py file, because I told you this is a template, and import numpy as nps, and I don't want video file. We will work on video capture as webcam, and this while loop. So now for face detection, we have to create the face detection object. Face detector equal to cv.cascade classifier. Okay, so I would like to say something here. OpenCV has done a great research on
cascade classifier, and they have given a nice library to use. I'm going to give the link. So this is the link where you can get cascade XMLs. So here all the weights are get trained, and they have kept around 15 plus cascades, and I'm going to take the default one, cascade front face default. I am clicking this. And here go to raw, click raw, and here right click and save as. You can save as a default. You have to save it in your own folder where your code is there. And also I am going to download cascade I. The same way we can download this. Go to the raw, right click and save as. I already have saved it, so it will ask save again, and you can save. Okay, so your cascade XMLs are ready now in your folder, the XMLs. Now I am going to load one of the XML here. So here you can copy the path, or you can copy the relative path. So relative path is same path here. And in between I am show and I am read, sorry, video read. I'm going to apply this face detector. So face detector, how in basic image processing, please watch the video and learn the basics in image processing, and you have nice toy application there. Check the links on the top corner and also in the description link. Here I'm going to give frame, and here the first point is x comma y. The second point is x plus width, y plus height. You can understand here. So the first top corner of the rectangle will be x comma y, and bottom corner of the rectangle will be x plus width and y plus height. Then I'm going to give the color. So OpenCV works on BGR format, so I'm going to give B. B is blue, and green should be 0 and red should be 0 here, and thickness I'm giving 2 here. That's all like in my side, and you can see here, and then the frame will be displayed automatically. And let's run. Okay, here you can see my face with the box. So this blue box is the face detector, and you can see these boxes. When I keep my hands, it goes because no face, and the face comes, it appears for you. This is a face detection from OpenCV. Now let's detect our eyes also in OpenCV. So here the same one, you copy the above thing and give the eye detector, change it to eye detector, and here you already have downloaded the eye detector. Here eye detector XML, and right click, copy relative path, and just have it. Okay, then so the eye detector won't work on the complete image, instead it works only on the face image. So let's apply eye detector on the face. So before that we have to crop the face. So I'm going to take face gray, let's call it as face image, and I'm cropping the face image here from gray. And so OpenCV works on x comma y comma in that coordinate information, but NumPy works on row and column. So you will get confused x comma y. So x, the first column, will denote a different one, and the second column denote a different one in OpenCV and NumPy. So when you manipulate any array, please use row comma column format, where if you work on OpenCV and when you apply that in any CV dot functions, so any CV dot functions, please use x comma y. If you work on any list or any NumPy array, use row comma column. So row comma column means the row denoted by y. So I'm going to give y is to y plus, it's y height, and so row will come from height, and here x is to x plus weight. Okay, so now your face image is ready. Now we are going to apply our eye detector. So eye detector dot same one multi scale, and I'm applying the face image. Then I'm drawing the image here. So instead of writing again, typing again, I'm copying paste and changing some things here. So instead of face, this is eye, and this is eyes. Shift and here eyes, sorry, eye. And here, right, already we have the variable x comma y comma wh in the top 18th line, the same scope. So what I am going to do, I'm just adding suffix in front of it, and here too. I'm going to change the color here. Instead of blue color, I'm going to show green color, and instead of frame, I'm going to draw frame only. Then yeah, and everything is good. Let's see here. I started. Okay, you can see the head, face, but you couldn't find the eyes. The eyes are displayed on the top. Can you understand why it's happening? Yes, you're right. So here, right, we are applying only face image on the eye detector. So the coordinates, everything, this eye detector knows only the face image, and it will detect the eyes on the face image. So we are going to project to the real image with the face x comma y. So x plus y plus, here x plus y plus. Now I'm running again. Okay, now you have face detector and eye detector. Then it's nice, right? You can play around, you try it out and write it in your command section. Thank you. Please like and subscribe this video if you like it, and in next video we will see what is neural network and how to train a neural network,
and how we can do classifications. And also in the coming sessions we will learn about how to do the hands-on object detection using deep learning, then the mask detections and RNNs, and a lot of interesting things. Thank you.